Crossrail is delivering a new railway for London and the South East. The project will link 42 kilometres of new rail tunnels in central London with national rail services in the east and west. It is building 10 new stations and upgrading many more in time for the operational service, which will be known as the Elizabeth Line when it opens in 2018. The construction programme is now focused on the complex task of fitting out the tunnels with the track, signalling, high voltage power, tunnel ventilation and overhead line equipment required to operate the railway. A major part of these works is the installation of the tracks. A variety of different track types are being used on Crossrail. 80% will be standard track, which is made up of sleepers on a bed of concrete with the track attached on top. The remaining 20% will vary between direct fixed track and floating track slab. Direct fixed track is used in the Connaught Tunnel, an old Victorian-era tunnel which has been repurposed for Crossrail. Direct fixed is exactly as it sounds. Track fixed directly to a bed of concrete without the need for sleepers. In sensitive areas of the route, floating track slab is used to absorb noise and vibration from passing trains. This clever but complex method cushions the track with the use of springs and rubber bearings. Helping to deliver these works is a new fleet of bespoke machines. 4 multi-purpose gantries are helping install the track and services required. These highly versatile machines are specifically designed for the confined and challenging environment of the tunnels. Operated by a single person in a cab, the gantry runs along the tunnel, staying level as the underground environment changes. A total of 57 kilometres of rail and over 70,000 sleepers will be installed in the tunnels. For each section, the gantry places 28 sleepers, followed by a 108-metre-long section of rail. Secured in place using clips, props and jigs, the rails are then joined together by a specialised welding machine. The tracks are then permanently fixed with concrete. In the eastern part of the route, a sophisticated concrete batching train is being used to set the tracks into place. At 465 metres long, it is the length of 4 football pitches. The train acts as a round-the-clock factory, with separate wagons carrying everything needed to produce the concrete. Dry materials and water are loaded onto the train during the day. Then, at night, the train mixes and pours concrete in sections. In the western end of the tunnels, where there is a mix of different track types, a concreting shuttle is being used instead. This is again transported into the tunnels for pouring. Other services needed to operate the railway are also being installed, such as high voltage power lines, communications, signalling and ventilation systems. The new electric trains will be powered by overhead lines on the surface and by a rigid overhead catenary system in the tunnels. All of these components are installed by drilling into the tunnel walls. As anyone who has drilled into a wall knows, there are areas which you should not drill into. The Crossrail tunnel lining is no different. Each tunnel segment has no drill zones, and we have to drill over 250,000 holes. To identify the no drill zones, the tunnel is 3D laser scanned and a digital model is produced. From this model, a precise drilling plan is created and fed into the state-of-the-art drilling rig, which moves along the tunnel, drilling holes accurate to the millimetre. The machine's hydraulic arms and dust suppression system ensure clean, drilled holes every time. Once the holes have been drilled, brackets and walkways are fixed to the tunnel to allow for the additional services to be installed. In station platforms, full-height platform edge screens are also being installed. With these giant machines and their specialist crews, the Crossrail project continues to move towards delivery of a world-class railway for London and the South East.